Hello, AP Calculus. This is section 3.3, the product and quotient rule and higher order derivatives. This will go fast, so let's start. All right, so product rule. Product means that we have two functions that are being multiplied together. We have an f of x and a g of x. And sometimes I will ask you to take a derivative of this product. Okay, now here's what you do not do. I'm going to put this right above. Do not do. Don't take the derivative of the first piece and just multiply it by the derivative of the second piece. That is a huge no-no, all right? That is what is the most common wrong mistake that you'll see for this type of question, all right? So don't take individual derivatives and then multiply them together. You have to use this procedure that you will see here off to the right. And the way it goes is this. You take the first function that you have, multiply by the derivative of the second, and then add to that, big add sign, the second function, okay, times the derivative of the first, okay? So you often hear this phrasing, it's first times the derivative of the second plus second times the derivative of the first, and that's it. So let's try this. Now, some people may ask as they look at this first problem, like, well, can't we just FOIL this out and then take the derivative? And the answer is yes. In fact, I would probably do that. However, for the purpose of just working with this formula, I'm going to use this procedure to answer this derivative question. All right, so I've got the first item, 3x minus 4, and I got to multiply it by the derivative of the item in the back. So individually, the derivative of x is 1, and the derivative of 2 is 0. Okay, so that part is done. We've already done this first piece. Okay, and now I'm going to put my add sign there. And now I'm going to do the second piece, which is the second, okay, times the derivative of the first. So the derivative of 3x is just a 3. And the derivative of 4 is 0. Okay. Now, you should clean it up a little bit. Okay. 1 times anything will just be itself. And then the second part, 3 times x is 3x. And 3 times 2 is 6. Okay. And then furthermore, we will add those together. And you will get 6x minus 2. All right. Know that on an AP test, once you do your derivative and input values potentially, you stop. Okay, so really, you could have stopped right here on a free response. Okay, so keep that in mind. Simplifying is not needed. All right, there's a time sign there. Same rule, product rule. First times the derivative of the second. Derivative sign is cosine. Plus the second times the derivative of the first. Derivative of the first guy is e dx is e dx. And you can really stop there. If you wanted, you could factor out an e to the x, but we're not going to take it that far. All right, now the next one is a little trickier. I'm going to have to write really small to fit this in. But you'll notice there's not 2 terms here. There's actually 3. There's, well, 3 terms with 2 different operations. One has a time sign, okay, between it, and the other one has a big plus sign in between it. So this guy right here, we're just going to do by itself, right? However, when I have an x multiplied by another type of x, okay, that means that we're going to use a product rule here. Okay, so the way you can tell we have product rules is you have more than one x being multiplied somewhere within your question. Okay, so if you see 2 x's, okay, multiplication sign in between it, that's a gimme. Okay, all right, so I'm going to put the 3 with the x to make that the first term, my f of x, and I'll make this kind of like the g of x. So I have first times the derivative of the second, derivative sign is cosine, plus the second times the derivative of the first. Derivative of 3x is 3. Okay, and the second part, it's, the derivative of 3 cosine x is 3 sine x. Okay, and then remember you have to put a negative out front because derivative of cosine is negative sine. And if I look at this, now again, on an AP free response, you wouldn't have to do much more. You could just leave it like this. but I'm going to simplify. I'm going to move that 3 out front. Okay, and these go away. So you're just left with 3x times the cosine of x. And there you go. All right, so that's the product rule. I think you've seen that before, but if not, I hope that makes sense. If not, rewind it and give it another try. And if it doesn't make further sense, then you let me know. Send me an email. All right, now here's the next one, quotient rule, which means we have a division sign here. All right, and so here's how it goes. So your f of x is on top, your g of x is on the bottom. You have low times the derivative of the high, okay, minus the high times the derivative of the low, all over the low squared. Okay, and it's a little different because you have a subtraction sign here. Okay, and second, you want to make sure that you multiply the correct way. So make sure it's low times the derivative of the high minus high times the derivative of the low, as you see it written out and scripted this way. All right, try not to get these guys reversed, which is a common mistake. All right, so here's what I do when I want to derive these. First thing I do is I just square the bottom because I don't want to forget about that. It feels like such a big chore to have this, and I'll just write it like that and I'm done, okay? All right, now second piece is I'm going to do low times the derivative of the high. Now let's be careful here. Derivative of 5 is 0, and the derivative of the subtract x component, that term, is just a negative x. Okay, sorry, is negative 1. All right, second piece is low times high times the derivative of the low. And the derivative of the bottom piece, well, 2x squared, the derivative of that is just 4x. And the derivative of 3 goes away. Okay. And from there, I forgot my prime sign, there's not much more you can do. Sometimes you can work the top out, and sometimes it'll factor, and one of the factors will be one of these bottom terms here. But I don't know if we'll have that. This ended up giving us negative 2x squared when you distribute that negative 1 through, minus 3. And then this is a subtract 4x. So 4x times 5 is negative 20x. And a negative give you a positive x, and that's positive 4x squared. All right, and if you want to do anything else, you just kind of write this 2x squared plus 3 squared. And maybe combine some terms. Negative 2x squared plus a 4x squared is 2x squared. Minus 20x minus 3. Okay, that's how the back of the book will write your answer. Okay, now on an AP exam, you could really stop here as long as you're plugging in numbers after that. All right, but the back of the book will share something like this. Okay. Again, most of the hard work is not sometimes the calculus piece, it's the algebra piece, which is just working this out and simplifying it. All right, so I'm gonna do this with a different color pen. Let's do this one with purple. All right, so same type of problem, it's a quotient rule. So I'm gonna say k prime of x, and again, I do this part, even though it's usually the last part of the little phrasing. I'll do that part first. Okay, make sure this whole bottom piece is in parentheses. Don't write this. I'm putting it up higher. I don't know if you can see it. That's difference, okay? But anyways, here we go. Low times the derivative of the high. Derivative of 4e to the x is 4e to the x. Okay, minus high times the derivative of low. Okay, and the derivative of sine is cosine. Okay, and really there's not much you can do. All right, you could pull out a 4e to the x if you wanted, but you don't really have to because it's not gonna cancel out with anything. You know, if it canceled out with something in your denominator, then it would be wise to do. But because it doesn't, you could have really probably just stopped right there. That would have been fine. All right, last one. This is a monstrous top piece. Okay, and we're going to do the quotient rule as we see it. I know that some of you may notice that you could pull out an x in the numerator and cancel out the denominator, but I'm not going to do that just for the sake of practicing the quotient rule correctly. All right, so this becomes 9x on the bottom, all squared. And here's what you do. Low times the derivative of the high. And let's see, the -2 will stay. And the derivative of 4x is 4. And the derivative of -5x squared is -10x. Okay. Need another parenthesis. Minus the high. Okay. All times the derivative of the low. Okay, and the derivative of 9x is just 9. Okay, now can I pull something out? Let's see. I think many of you are thinking, I thought we could just stop. And sometimes you can. Here's what I know. I can pull out a 9. I don't know if I can pull out an x. All right, so what's left over? Geez, there's an x right here. And you can multiply that -2 through. So -8 plus 20x. Okay, and then this becomes an add 2. So 2 times 4 is 8x. And minus 10x squared. All right. And let's see. Just make sure my parentheses look good. I think I have too many parentheses. I do. Hold on, let me erase one because I'm not quite right. And I hope it doesn't erase too much. I'll just tap it. I am usually not that smooth, but it worked that time. Okay. All right. So I pulled out this 9 and I pulled out this 9, and I think I'm okay. So one of these 9s will cancel out with this 81 down here. And I'm almost out of space, so I may stop soon. Don't cheer. Okay, distribute your x through. And distribute this x through. That gives you 20x squared. And this is an 8x. And a minus 10x squared. All right, now if I've done my math right, the minus 8x and the positive 8x go away, and you're left with 20 minus 10 is 10 all over 9x squared, which should be 10 over 9. I'm going to pause this just to make sure I'm right, because I didn't think it would come out that smooth, all right? And I don't want to redo this. So give me a second. I'm going to pause it. I'm going to check it, and then we'll see if we can move on or not. Hang tight. Guess what? We got it. We got it. Let me just show you right here. Where's my pen? If you had distributed this through, you would have had -8x over 9x. And distribute the -2, you would get plus 10x squared over 9x. Right? And these x's are going to cancel, so the derivative of -8 over 9 will also go away. These cancel out, and it leaves you with just an x. And if you take the derivative of 10x over 9, you do get 10/9. You guys are awesome. All right, let's keep going. All right, so here's what I got. We know the derivative of sine is cosine. We know the derivative of cosine is negative sine. I got 4 more for you. If you're like, no, I'm sorry, we do. And so these are the 4 you have to know. The derivative of tangent is secant squared. Derivative of secant is secant tangent. Derivative of cotangent is negative cosecant squared. And the derivative of cosecant is negative cosecant cotangent. You got to know those, okay? They're not negotiable, okay? And you just have to sit down and memorize them, okay? Make yourself some flashcards and be confident with them because they don't go away, all right? Learn them. Now, here's the deal. There's the tangent of x. Like, how did they come up with this, right? Well, remember, tangent is really the sine over the cosine. And so here's what I can do. I'm going to do the derivative of tangent in this form, and I'm going to use the quotient rule. So low times the derivative of the high, the derivative of sine is cosine, minus high times the derivative of the low, which is derivative of cosine is negative sine, all over low squared. Now I can write it like this, okay? Or if you wanted to, I'll just put it up here. That's the same thing, okay? All right, now on the top, it's cosine squared x. Subtract a negative, which really makes this an add sine squared x. And what's cosine squared x plus sine squared x? It is 1. And what is 1 over cosine squared x? Well, it is this guy right there. And you could do them all that way, okay? Secant is the same as 1 over cosine, quotient rule. Cotangent is cosine x over sine x, quotient rule. Cosecant x is 1 over sine x. Again, use the quotient rule, you could find this. Okay, so that's why they give you these 4 things in this section. All right, so find the derivative, easy. Well, I know the derivative of x. And remember, this is not a time sign, so I don't have a product rule here. It's just a plain take the derivative of x, which is 1. And the derivative of cotangent, well, that's kind of handy. It's right here. It's negative cosecant squared x. Okay, now you may not know this, but we all know that sine squared x plus cosine squared x equals 1. And we also may remember that 1 plus tangent squared x equals cotangent squared x. Okay, and 1 plus tangent squared x equals secant squared x. Sorry, I'm not stopping. I was on a roll too. Secant squared x, okay? And the last one is 1 plus cotangent squared x is equal to cosecant squared x. Okay, so here's the deal. This actually simplifies a little bit, okay? And so here's what I'm going to do. If I subtracted this 1 over, all right, I would get almost what I have here. It's just the opposite of it. Okay, so basically if I multiply through by -1 to everything, including this guy and this guy, notice that this part here now matches what I have here. So 1 minus cosecant squared x is the same thing as negative cotangent squared x. You're like, man, I didn't remember that. That doesn't surprise me. Okay, these are the ones right here with the sines and the cosines are pretty normal, but the other ones, I know you've had exposure to them, but you don't use them as much in practice. Okay, so, but that's your answer. All right, the second and final one is, well, if I take a look at it, it's x times the tangent of x. I'm writing a little bit more over here because I wanted a little more room. And this is, again, a product rule because there's a time sign there, okay? So y prime is first times the derivative of second. Derivative of tangent is secant squared. And the derivative, first time derivative second plus the second tangent of x times the derivative of the first, which is x, is just 1. Okay, and at this point you may stop. This will not simplify further. So I don't think. It doesn't. Awesome. Okay, here's the last piece. And this is as important as any other item that you've been seen previous, okay? These are AP test questions here, all right? They try to think of abstract ways to ask derivative questions, and they will say ahead of time, hey, if h of x is equal to f of x times g of x, notice we have some products here, use the chart to find h prime of 3. So here's h of x. I want first h prime of x, and then I'm going to want h prime of 3. Okay, so it's hard to answer this question unless you look at this first. Okay, now h prime of x means I need to expand this the way that I showed you in the very beginning. So I'm going to flip back a little bit, okay, to this formula right here. Okay, now they're not always going to write it for you, so you're going to have to know it. Okay, so h prime of x, when you do that, means expand this guy here. And sometimes it's a product rule, sometimes it's a quotient rule, sometimes, like you'll see tomorrow, it is a chain rule. Okay, so first times the derivative of the second plus the second times the derivative of the first. Okay, and then from there, as long as I've got that and I'm comfortable with it, I'm going to input 3. Okay, so anytime I see an x, now I see a 3 in that location. Okay, so now I'm going to use this chart to help answer this question. All right, the rest is pretty simple. All right, just don't make a slow mistake. F of 3. Well, here's f. Here's my column with 3 in it. Sometimes they'll give you more columns with more numbers. That's a -1. Okay, g prime of 3. Here's g prime, and g prime of 3 is 4. G of 3. G of 3 is -3. And f prime of 3 is 1. Okay, now again, on an AP test, you could just stop there. But I'm going to finish this because I feel silly if I don't do that part. Okay, but AP test, you better quit right there. Okay? All right, so I'll promise you this will be on your test. And here's what people do. They'll say, h of 3. And the first thing they do is say, what's f of 3? And then what's g of 3? And they just take these two numbers and plug them in and they multiply it. And they never even took the derivative by expanding it. Okay, so don't be one of those people. If you do that on your test, okay, I'm going to give you one of these faces here. I'm going to like that. And that's going to be the signal that says, you know what? You didn't listen to Rothery. All right, here's the last one. Same idea. Okay, the only difference is I have a quotient rule here. Okay, so h of x equals f of x over g of x. Use the graph instead of a chart to find h prime of 1. Okay, then do this, guy. It's a brand new problem. Okay, to find h prime of 5. All right, so let's just do h of x first. H of x is what we see here, and now let's do h prime. Okay, so we will expand this, and it is low times the derivative of the high. So I'll put my little time sign there so I know I have an operation. The derivative of the high guy minus high times the derivative of the low, and the derivative of gx is just g prime of x, all over low squared. All right, and so from here I can answer the other two questions. I need h prime of 1. So what that means is anytime I see an x, I'm going to put a 1 in there. Again, what's the silly mistake people do? They'll say, oh, let me just find f of 1 and g of 1. It's like, no, don't do that. Okay, so g of 1 times f prime of 1 minus f of 1 times g prime of 1. And this is g of 1 squared. Okay, now, sometimes it's to our advantage just to write these out, but you don't really have to. I'm going to just find what f of 1 and what g of 1 are first. Now, remember, if I say f of 1, what that means is I got to look at the f function, which is over here, and find the corresponding y value. So the function that's written in black here, that's your f, and at 1, right there, it has a y value of 6. So I'm going to write this off to the side. And for my g function, at that same x value, my y value is 4. Okay, now I also need some f primes and g primes at that same spot. And remember what the prime means. This means a derivative. Okay, so if I want the derivative at that spot, and I'm looking at a graphical representation, what I really want is the slope at that spot. And if you can differentiate this top piece with the bottom piece and know what to look for, the rest is fairly much just arithmetic. Okay, so let's take a look at that. F, that's not a division sign, that's just separating the F's and G's versus their derivatives underneath. F prime of 1, so if I look at 1 and ask you, what is the slope of this line here? It's very simply recognizable. It looks like about a slope of 1. Okay, and then G prime at 1 is right here. It looks like the slope is, I'm going to find some points that are touching some lines nicely. Okay, so it looks like it's down 1 over 2. So if I go down 1 over 2 as you move from left to right, that is -0.5. Okay, and don't forget the negative. That's important. All right, and now you got to plug it in to this monster. Okay, so G of 1 is 4. So I'm going to write 4 squared on the bottom. Okay, and then my G of 1 is still 4 times F prime of 1, which is 1, minus F of 1, which is 6, times G prime of 1, which is -1/2. Now, I'm going to do something very unorthodox in a math class. I'm going to stop right there. And you're like, Rothri, that just feels uncomfortable and not complete. But I'll tell you what, as long as I've done all my math right up to this spot, I can't gain more points by doing more work. All right. If this is like a 3-point question on your AP exam, if you've gotten to here, that's the most you can ever get. Okay. You can't be the good person and do more and expect to get a 4 when it's only worth 3. Okay. In fact, the only thing that can happen is you can make a mistake and they'll take a 3 away and give you a 2. All right. So stop. And then in your head, be like, I don't like that. And that's fair. But in the end, you want to maximize your opportunity to get points. Okay. All right. H prime of 5. I can use this same formula as before. That's this guy. And here's what I got. This is not this. Let me start over. Boom. Now let me get rid of that 5. New color, green. Okay, so here's what I gotta do. I gotta take the derivative of this. And this isn't a quotient rule. This is actually a product rule. All right, so first times the derivative of the seconds, okay, plus the seconds times the derivative of the first. Derivative of 2x is just 2. Okay, and now I'm going to plug in 5. Okay, so I'm going to simplify a little bit. I can't stop here because I don't have inputs for g of 5 or g prime of 5. This is 10 times g prime of 5. Here's 5, and if I go up here, now do I put the number in this spot? This looks like a 6. Not here. I put it into the g of 5. Is that right? So when I see g prime of 5, I'm looking for the slope at 5. Okay, and at 5, it looks like the slope is passing through. It looks like -1. Okay, and then the second part, your g of 5, we said was just a second ago 6. All right, and if you want, you can do more, but at this point, you are allowed to stop. Okay, and you'll get full points in your AP test for it. Okay, so if you did it, I think you get 2, but here, stop. All right, I don't think I have anything else. That is your assignments. Okay, so bust that out. It feels like a lot, but some of these are kind of small. Okay, they don't take a long time to do, especially when you have these charts like that. You'll have some ones that look like this where you have some derivatives of these guys. Be careful the ones that also have a product rule maybe to it, or a potential quotient rule. They may ask you to prove some of these, okay, the ones that you have on those screens. I just did secant, was the derivative of tangent, but there may be some others, okay? All right, if you have any questions, holler at me, and I will help you out. I hope you have a great day.